Welcome to another video about hypernodes. This is part 2 in the series about what the individual nodes do and building graphs. So last time we went over flow control. We've already talked about AI. Let's talk about the text nodes. And the text nodes, while they're not quite as fancy, there's not as much AI in them, but they're very helpful for making a real program, really. That's not just, a cookie cutter template that so many of the other tools are. So let's get into it. Let's start with the union node. So we're going to learn the union node first. When you have a link between two nodes, the data that flows between the link, it's all text data. But it's not just one block of text. It's a list of text items. So it's a list of strings, a list of sentences, a list of conversation responses. And a lot of the time, there's just one string in that list, just one response in the list. If you have a conversation, you need to send the history of the conversation. Each item in the conversation will be a separate string in a list. So there's multiple items in that list. So the union node is for working with the list instead of the text. And it simply just adds multiple items together to make a larger list. Or it adds multiple lists together. So you could say 1 plus 1 equals 2. And let's use an also node from the input to activate this. It's not going to connect to the input node at all. So obviously the first one is the first in the input docs, and you can just add as many as you like. So 1 plus 1 equals 2. Save my graph. It doesn't matter what I put into it, so I'll just leave output there, because as you can see, the input is thrown out, and the output will be based on these hard-coded data nodes here that I wrote when making the program. So let's see how it happens. You can see it does put them together, but it puts them together as separate items in the list. And you'll see in the text nodes we have, there's a lot of ways to work with the lists versus just having one string that's all clumped together. It's a little harder to separate that out or work with individual items. That's it for union node for now. If you want to paste together 1 plus 1 equals 2 into one message, you're probably not going to want the union node. You're going to want the concat node. So we'll see the difference here. It looks the same as the union node. You can just add as many inputs as you like in. I'm going to have to do that. But as you can see, it's all one message. So if you look at the tooltip, you'll see if there's more than one item in one of the lists in its inputs, then there will also be more than one item in the list in the outputs, and they'll all be composed of an item from each of the inputs. So to illustrate, I'll create an input that has 2 items in it. Let's see what happens. Do you see how that works? It's just like the tooltip says. It zips together the 1 plus 1 equals, and then for each of these in the list here, it'll paste one of those onto the 2, paste one of those onto the 3. And this is useful if you want to, say, have a prefix on the entire conversation. But mostly concat_node is just for pasting together multiple elements into one string. Okay, that's it for concat_node. Let's go to last message node. For this one, actually, why don't I bring back the union node again, because this works with the lists. Mostly you will be seeing this in a conversation, so why don't I put a mock conversation here instead. Let's run it. And as you can see, the last message node gets these 3 items, and the result is the last item in the list, and the list items are separated by these commas here. Okay, let's move on. The next one is parse array node. Parse array node is, it lets you turn a string into a list. And I'm gonna show you why that might be useful in this example. Why don't I have like an example where you have a list of items and order matters in this list. And you can get ChatGPT to write these lists for you. For example, generate a character sheet in this format, and then you provide an example template. Once we have that successfully made, how do we get some data from it? Let's say we have this list that ChatGPT output. And this is just a very simple character sheet. The first item is the name, the second item is the level, third items are the items that the character owns. And if we just return the result of this parse array node, I gotta put it in the also node so the execution will reach it. Well, you can see that it splits it out into a list when it was just one item. So you might say, oh, look, it seems the same. Well, yes, unless you want to do something with the items in the list. Let's take a look at the next node, rotate node. This is the next text node that we'll take a look at because it pairs well with parse array node. So if we just take this and put it in the middle, well, what are we going to see? Because rotate node, you can look at the tooltip. Takes a list of inputs and a list of outputs and swaps between vertical and horizontal orientation. Well, what does that mean? Well, let's see what it means. So, you get this big string representing a list. You get the list from parse array node. And now, rotate node outputs the first item in the list? Well, yes. This is because it's the first output of rotate node. Let's try this. We could use the second input. You can add as many inputs or as many outputs as you want to rotate node. But in this case, you'll only get something if on output 1, 2, or 3 because there's only 3 items in the list. So let's see what the second item from rotate node is. Yeah, that's the level. And then the third item, of course, is going to be what items he has. Yep. Very good. So that's parse array node and rotate node. You can also use it to mash items together into a list. This is the same functionality as union node. So watch how this works. as you can see, input is kind of exploded out into each component in the list, and then it gets merged back by this other rotation. So that's basic use of rotation node, basic use of parse array node covered. We can check out sliding window node. Sliding window node is going to be a pain to demo, so I'll just explain it. It just crops the messages so that the latest messages are sent into the output under this word limit or this token limit. And this works with multiple messages, like in a conversation. It also works with just a single message. It will cut off even just one message. All right, well, what's next? Split node. Split node is kind of like sliding window node. Instead of cutting off the last, it takes a large string and will break it up into lists so that each of the items in the list falls under the word limit. Now, split node, I don't find it useful all that much anymore. It's mostly easier to just use the collapse node in situations when I would want a split node. Because the collapse node it'll do a split internally anyway. You don't have to worry about the context limit if you're in a collapse node. But you might find a use for it. It's still in there. There are still some graphs that use it. String concat node. We have a list of strings from this parse array node, very convenient. Let's put it into the string concat node and we'll get back one single string representing our entire character. We could just use this, but say we didn't have this conveniently available. Okay, it's not terribly readable, but you can see it just pastes together the items in the list. So that about covers our text nodes. So you should have all the info you need now to build some basic graphs. If you know flow, you know AI, you know text, pretty basic. But next we'll cover storage, which it's certainly useful for building larger programs. Hope you enjoyed the tutorial video. All right, later.